for graphing y equals the absolute value of x, you're going to start here at 0, 0, and then this is our V-shaped graph whenever we see the absolute value bars around it. So I'm going to be going over 1 and up 1 on both sides in order to be able to get my graph. With the square root function, our graph is going to end up looking kind of like the square root symbol, just a bit more curved. It again starts at 0, 0 because the square root of 0 is 0. And then we go to 1, 1 because the square root of 1 is 1. But then we don't go over 2 next because the square root of 2 is a decimal. We want to stick with whole numbers here. So then we go over 4 and up 2 because the square root of 4 is 2. And so then the next thing we do is we go over 9 and up 3. And whenever I say over and up in this case, I'm counting from that very first point that I plotted there, counting from 0, 0. And then we draw on our curve from there. All right, next up, we're going to look at x squared here. When graphing x squared, we should see that power of 2 and automatically think of that parabola shape, that U-shaped graph that we have. I'm going to put my first point here at 0, 0 because 0 squared is 0. And then I'm going to go over 1, up 1 on both sides because 1 squared is 1. And then if I go over 2, I'm going to go up 4 because, again, I'm squaring whatever x is. And so if I square 2, I get 4. In the same way, if I go over 3, I go up 3 squared, which is 9. This equation looks a lot like the last one. The last one was x to the power of 2. Notice this one is 2 to the power of x. We still got an x, we still got a 2, it's just that order changed. And in changing the order, we changed which part is in the exponent. In this case, the x is in the exponent, which fundamentally changes what we're looking at here. So this is an example of our exponential graph, the most recent one we had learned about in class. This is the one that's very flat on the left-hand side, and then it gets steeper and steeper as we go to the right. This is also the one that has the asymptote in it. So knowing that, the very first thing I'm going to do is draw in that asymptote. Now, because this particular one has not been shifted in any way, the asymptote's there at 0. And then from there, my first point, remember, does not go at 0 on this one because 0 is the asymptote. To the power of 0 is 1 because anything to the power of 0 is 1. And then to the power of 1 is 2, to the power of 2 is 4, and to the power of 3 is 8. And so you notice what we're doing is as we go to the right, we're doubling the height. We're doubling that distance that we are from the asymptote as we go to the right. On the left, we're going the opposite. So instead of multiplying by 2, we're dividing by 2. So we're going to be dividing by 2 and get a half. If we divide that by 2, we get a quarter. Divide by 2 all the way down. All right, and then for this final equation, we got f of x equals x. Now we've been saying y equals, we've been saying f of x equals. Remember, they mean the same thing. So when I say f of x equals x, that is the same thing as saying y equals x in terms of our graphing part here. But how do we graph that? Because it's just an x. There's no squared on it, no square root, no absolute value. There's none of that funny stuff there. Well, when that happens, that means it's just a line. Specifically, the line that starts at 0 and then has a slope of 1. So from 0 here, we're going over 1, up 1, over 1, up 1, over 1, up 1, all the way along there to get our new line in this case.